Okay, so moving on to 4.2. And now 4.2 is called point slope form. What we did in 4.1 is we had just a little, let's just do a little intro, little warm up here. So before section 4.1, we were given points in y equals mx plus b and asked to write equations, but our b always had this x of 0. So I knew, well, b is always going to have the x of 0, but it was given to me in the problem because A, I could see where it crossed the y-axis, or B, it was listed as an ordered pair, but I knew my x was 0. So whatever my y happened to be, that was my b. Now though, what's going to happen when this x is not some other number, or is not 0, it's some other number? It doesn't tell me. It eventually may cross the y-axis, which all lines will, except for a vertical line, unless it's on the y-axis itself. But that 0 is now going to be changed to something else, and we're going to be able to find this b to write the equations. And that is what we are doing. So here we go. This is 4.2, and this is point slope form. And point slope form has a definite equation, and I'm going to write it, and we're going to do it a couple of different ways. But this equation right here, I'm going to show you, I'm going to introduce it, but then as we go through the notes, you're going to see how I do these, and that is what I'm going to how I would like you to do these. Here's the equation. Y minus y1 is equal to m times x minus x1. M is still going to be your slope, and these are going to be the ordered pairs. Really, you're subtracting your y's. You're taking your change in your y. If I think about it, my change in my y, I'm going to multiply that m by the change in my x. Let's think about that for a second. M is equal to change in y over change in x, right? If I solved for this m here, wouldn't I divide by x minus x1, which I would divide both sides by, and wouldn't I have my y divided by this, and I would have my slope? You certainly would. You certainly would. It's derived right from that. So here's what we're going to do. We are going to write an equation, and you guessed it, in point slope form and slope intercept form. Of a line that passes through -8, 3 and has a slope of 1/4. So there's our problem. Write the equation in point slope form and in slope intercept form of a line that passes through -8, 3 and has a slope of 1/4. So what's different about what we did before? I'm always going to say you need two things to write it. You need a slope, you need a y-intercept. It tells me the slope, but this x is not 0, so I don't have my y-intercept. My y-intercept, it ain't 3 because my x is not 0. So I'm going to have to find out what that is. Here's how you use point slope form though and how it can be helpful. I remember using point slope form more in like calculus, maybe something in college. I used it a couple of times, but I don't remember a ton of it in algebra. Which is why that I'm going to show it to you, and we're going to kind of do it the same way, but go about it a little different. So point slope form. If you have a point, that is your x1 and your y1, and you have a slope, which is your m, you have what you need to plug into this equation. Y subtract y1, y subtract 3 is equal to my slope, 1/4 times x minus x1, which is a minus 8. I'm going to simplify this a little bit. So this will be y subtract 3 minus minus slash slash becomes x plus 8. I just wrote the equation of a line in point slope form. This is the equation in point slope form, but this really doesn't help me do anything. It doesn't help me graph, doesn't help me identify the y-intercept. I certainly know the slope, but if I wanted to write this in y equals mx plus b, I am just going to distribute that 1/4 and then rearrange it. So if I want to write it in y equals mx plus b, I'm going to rewrite this. Y is equal to y minus 3 times 1/4 times x plus 8. And if I asked you to solve for y, hopefully you would say, okay, I'm going to distribute. So I have y subtract 3 is equal to 1/4 times x, 1/4 times 8, or 8 divided by 4, plus 2. I now would have to add 3. Y then would be equal to 1/4 x plus 5. And I've got it in y equals mx plus b. And now I can certainly identify my b or my y-intercept there. Why don't I like using this to write equations when I'm given a point and a slope? Because of so many mistakes that are made in distribution here. And I think we are going to go through, I know I am going to give you a little bit easier way to do this. So here we go. I'm going to flip this over. Next thing we are going to do is we are going to write, why is that not focused? There it is. Write the equation of the line. Now though, we are going in slope intercept form. I will give you exactly one problem. And yes, I want you to memorize it. And yes, I want you to know y minus y1 is equal to m times x minus x1, because there will be a question that will just say, write the equation in point slope form, just like what we did on the front. But the majority, we're going to always want to write in slope intercept form. So that's what we're going to concentrate on. I'm going to tell you that these passing through the given points. So here we go. Write the equation of a line in slope intercept form. Y equals mx plus b, passing through the given points. Let's say I have the ordered pair 7, 2, and the ordered pair 2, 12. And no, we do not want to graph these. We're going to do these all algebraically. Two things you need to write an equation of a line in slope-intercept form. You need a slope and you need a y-intercept. I can't find the slope without doing change in y over change in x. I could graph it and do rise over run, but we ain't going to do that. None of these x's are 0, so I'm going to have to find my b. Here's how we do it. First thing, find slope. You got to find your slope first, and we got to take care in finding the correct slope. Because if I screw up how I find my slope, when I use that slope to find my y-intercept, I'm going to get the wrong y-intercept. So the first thing is take a lot of care in finding this. Slope is change in y over change in x. Circle my y's, left to right. 2 subtract 12, divided by 7 subtract 2. 2 subtract 12 gives me a negative 10. 7 subtract 2 gives me a 5. Negative 10 divided by 5 is a negative 2. You have one piece of the puzzle that you need to write this equation in slope-intercept form. We want to write it in y equals mx plus b. We know that our slope is negative 2 because we took care in finding that. I don't know what my b is. But couldn't I find out what b is if I had an x and a y? If I knew y and I knew x and I knew slope, I could certainly solve for b. So what are x and y? Well, x and y are right back up here. And since both of these points lie on the line, I can choose either point. Does not matter which point I choose to find my b. You can choose either one of them. I always go through and look though. When I'm finding my b, I like to choose numbers that are small and maybe if one of my points is positive, because that seems to make the math a little bit easier. When I don't have negatives, if I have smaller numbers and no negatives, I choose that. These are both relatively small. There's no negatives. Doesn't matter what I choose. I don't know, let's just choose 7, 2. So I have an x of 7, a y of 2, and I could easily chose an x of 2, and I could have chose my y of 12, and you are still going to get the same answer. Plug in what you know. Y in this one is 2. Your slope is negative 2. Your x is 7, and you are looking to find b. Now all I got to do is find b. 2 is equal to negative 14, because negative 2 times 7 plus b. I would add 14, and now I have 16 is equal to b. You have the two things you need to write the equation. Y is equal to negative 2x plus 16. We have just wrote the equation of the line that passes through these 2 points. In order to write y equals mx plus b, you need to find the slope. We do that by changing y over changing x. Once we have that slope, we choose either one of these points because they both lie on the line. You have an x and a y. We substitute either one of these. I can't go back and forth. I have to choose one point. I can't say it's 7 and then choose this y is 12. They have to go together. So I could choose an x of 7, a y of 2, or I could choose 2 and 12. Substitute those right back into your equation, solve for b, and you have it. And I want to just do one more in point slope form. Because I can certainly use point slope form whenever I'd like, and some students do. Some students keep doing this, and I don't care which way you do it. I'm going to do them all like this from here on out. But if I was going to use point slope form, you still would need the slope, which we found was -2. And then again, either one of these points. I'm going to choose this x and y this time, my 212, and use point slope to show you that we will get the exact same equation in slope-intercept form. So I'm going to have y minus my y1, which is 12. That will equal my slope, which is -2, times my x minus my x1, which is 2 here. Now I can solve for y, and I'll have it in y equals mx plus b. Y minus 12 is equal to -2x plus 4. Just like we did in the front. I got that -2x plus 4 by distributing that -2. I can now solve for y by adding 12, and hopefully you can see this coming together. And I get the exact same thing. Using point slope form and using a different point, the equation of the line is still going to be the same. This works. I'm going to do mine this way. Here's another example. Let's say I have the ordered pair 6, -2, and I have the ordered pair 12, 1. Write the equation of y equals mx plus b of slope-intercept form of the line that passes through these 2 points. The 2 things you need, slope and y-intercept. I can find my slope. Change in y over change in x. I will circle my y's, and I will subtract them. -2, subtract 1, divided by 6 minus 12. -2 minus 1, -3, 6 minus 12, -6. That needs to be simplified. Negative divided by a negative is a positive. 3/6 is equivalent to 1/2. I now have one piece of the puzzle. Now remember, we want to write this in y equals mx plus b. We know our slope is 1/2. I don't know what b is. I need those two. You have an x and you have a y. Which one do you want to choose? Well, I don't really care. Doesn't matter. 12 is bigger than 1. This -2, it doesn't matter which one I choose. You can go back and forth. I'm going to choose the positive ones on this one, and then I'm going to do it the same way, and I'm going to choose this point. But I'm going to say my x in the first one is 12, my y is 1. And again, it doesn't matter which point I choose. I now have everything I need to plug in to solve for b. 1 then would equal my slope, which is 1/2 of my x, which is 12, plus b. 1 is equal to 1/2 of 12 is 6, plus b. I would subtract 6. -5 then is equal to b. You have the 2 pieces of the puzzle you need to write your equation in slope-intercept form of y is equal to 1/2 x, subtract 5, and I've got it. And I could certainly use that other point. I still have an m of 1/2, and if I wanted to use y equals mx plus b, I could certainly take -2 is equal to 1/2 of 6 plus b. -2 is equal to 1/2 of 6 is 3 plus b. I would then subtract 3. -5 is equal to b. And I get the exact same answer using every point, or using either point. And I did that without using point slope form. It's still kind of point slope form because don't I have a slope and aren't I using a point? We are, it just doesn't hold this. Just to recap, 2 points that lie in a line. And if you want to write the equation, find the slope by changing y over changing x. Pick one of the points, substitute an x and a y in, solve for b. Every single time, that is what we are going to have to do.